we're asked to use Cramer's rule to solve the system of linear equations. Notice how we have 4 equations with 4 unknowns. The variables are x sub 1 through x sub 4. Let's look at the notes on the right for Cramer's rule. Cramer's rule states, given the matrix equation Ax equals b, where A is the coefficient matrix, x is the variable matrix, and b is the constant matrix, with A an invertible matrix, then x sub I is equal to the determinant of A sub I divided by the determinant of A, where A sub I is a new matrix formed by replacing the ith column with the constant column matrix, matrix B. Let's begin by writing the matrix equation for the given system. Because we have 4 equations and 4 unknowns, matrix A, the coefficient matrix, will be a 4 by 4 matrix, the variable matrix X will be a 4 by 1 matrix, and the constant matrix B will also be a 4 by 1 matrix. I highly recommend labeling the columns of the coefficient matrix to make sure the coefficients are identified correctly. And the variables are x sub 1 through x sub 4. Looking at our first equation, the coefficient of x sub 1 is negative 2. The coefficient of x sub 2 is 0 because there is no x sub 2 term. The coefficient of x sub 3 is 3. The coefficient of x sub 4 is 0 because there is no x sub 4 term. In the second equation, the coefficient of x sub 1 is 0. The coefficient of x sub 2 is 1. The coefficient of x sub 3 is 0. The coefficient of x sub 4 is negative 3. For the third equation, the coefficient of x sub 1 is 2. Coefficient of x sub 2 is 3. Coefficient of x sub 3 is negative 2. And the coefficient of x sub 4 is 0. And then for the fourth equation, the coefficients of x sub 1 and x sub 2 are both 0. The coefficient of x sub 3 is negative 3. The coefficient of x sub 4 is 2. And then we have times the variable matrix, where we have a column matrix, and the entries are x sub 1 through x sub 4, equals on the right matrix B, which is a 4 by 1 matrix containing the constants on the right. We have 13, 0, 0, negative 15. And now we can apply Cramer's rule to solve for x sub 1 through x sub 4. Notice all the denominators for x sub 1 through x sub 4 are the same. We have the determinant of matrix A, the coefficient matrix. And now let's focus on the numerators. For x sub 1, the first column has been replaced with matrix B, the constant matrix on the right, and columns 2 through columns 4 remain the same. For x sub 2, the second column is replaced with matrix B, and columns 1, 3, and 4 remain the same. For x sub 3, the third column has been replaced with matrix B, or the constants on the right, and columns 1, 2, and 4 remain the same. And for x sub 4, the fourth column is replaced with matrix B, or the constants, and columns 1 through 3 remain the same. And now we just need to evaluate the determinants. And because these are 4 by 4 determinants, I already evaluated them with a calculator, where all 4 denominators are equal to negative 58, and the determinant of a sub 1, or the numerator of x sub 1, is equal to negative 106. Simplifying, we have x sub 1 equals 53/29. For x sub 2, the determinant of a sub 2 in the numerator is equal to negative 144. Simplifying, x sub 2 is equal to 72/29. And for x sub 3, the determinant of a sub 3 is equal to negative 322. Simplifying, x sub 3 is equal to 161/29. And finally, for x sub 4, the determinant of a sub 4 is equal to negative 48. Simplifying, x sub 4 is equal to 24/29. I hope you found this helpful.